On the bench today we have a Lafayette Telsat SSB 100. This one was also supposed to be for VFO, but this one's got other problems. This one does not transmit nor receive. It turns on. It's missing some meter bulbs. It's got one meter bulb out and a bulb out on the channel indicator. But we got to get it operational before we even think about putting a VFO in it. Okay, let's start out, see what we're missing in the crystal section. Not having any transmit or receive indicates that we're not getting our crystal mix through the mixer here. So let's take a look and see what we're missing. Let's start out with our 23 megahertz, and we seem to have our 23 megahertz for channel 1, 23 3299, which is okay. We're supposed to be at 2333. Okay, let's check our 14 megahertz, which is on this one, and we don't have anything. So we are missing our 14 megahertz. Either we're not getting the crystal through to the oscillator, or there's something wrong with the oscillator. I've already checked the oscillator, and which is a transistor right down in here, right there, and we have our proper voltages. So for some reason the crystal's not making it through the channel selector. So we've got to pull the channel selector, check our connections on it. I've already sprayed it and cleaned it, and we still have nothing. So we'll pull it, find out what's going on. Well, I pulled the channel selector out and re-exploded a lot of the solder. It didn't do any good. Turns out I wound up having to pull the channel selector apart, the circuit board. The very first circuit board here on the internal, it's cracked and broke. So it broke 4 traces inside there. I'll go ahead and try to repair them, but if that doesn't do any good, what we'll do is we'll just bypass the channel selector, since it's going to get a VCO. We'll just solder a wire from the crystal over to the oscillator, and that should bring us back for channel 1, and that's what we need for the VFO. As you can see, we got our 14 megahertz back on the scope. Well, that's how I soldered the traces. I brought that back. Now we've got unbelievably loud on the receive. Just turn the volume all the way down. You must forget it's still deafening. So we got to find out what's going on there. But we found what was wrong with the with the channel selector. Yeah, well, the channel selector is in such bad shape on this unit. I'm going to have to bypass the channel selector. So we'll take our crystal up here, our very first crystal here, and connect it directly to the oscillator and shut the selector down, so it won't matter at all where the channel selector is, what channel it shows. It's going to be only this first crystal and the crystal that was taken out. It'll be going directly to the oscillators. They won't even go through the channel selector. Okay, according to the schematics here, our 14 megahertz crystals come in here at this point, junction 191. That's at RFC 202 and R222. So what we'll need to do is cut the tracer here, and then bring the 303 crystal, or not the 303, the 907, 14907, come off of 183 and jump right to 191. Jump right straight across. With cutting the tracer here, anything else that if the dial gets selected, it'll be ignored, because none of that signal will get through here. So, but going from here to here, just a straight jump, it'll bypass the channel selector completely. Now for the main selector for the 14.3, we're coming in through the crystal slot, which we're still counting on the channel selector. So we'll need to cut tracer going to R202 from the channel selector, and then feed our 14 or our 23.3 right directly to the oscillator. Of course, still with the capacitor for a DC block, but it'll bring it directly in. So we'll be bypassing the channel selector completely. Well, that should take care of our 14 megahertz crystal. It completely bypasses, I cut the trace here, completely bypassed the channel selector, went from the positive side of the crystal to directly to the coil that runs to the oscillator. So now we'll work on our 23 megahertz side, bypassing the channel selector and connecting it. We'll have to find out where that one is. Now that we know the channel selector is no good, so we're bypassing it. Came into R201 and R202, which goes to the base of the oscillator. Took and isolated that from the channel selector and took the first crystal out, even though we weren't going to use it anyway. But cut the tracer on that going to the channel selector and ran my coax across to where the crystal was. And then used the bypass capacitor, or the DC block capacitor, 0.01, from the coax to the base of the oscillator. That should take care of it, and I don't have to use any black tape or insulator. There's nothing there that should short out. Okay, let's put the channel selector back in and see if she turns on. You know, we run into another little problem. Got the radio aligned, and VFO is working really good. But where we ran into our problem is the volume control. Let me see if I can. There's a lower sideband. Seems to work, but watch what happens when we go to AM. That's all the way down. So I think I have to put a volume control in it. Well, replacing the volume control did it. The volume control itself just wasn't going down far enough. It was leaving 30 ohms, and needed to go right on down to 0. And took care of that, and the volume's working great now. Okay, let's do a little bit of a receiver test. This is lower side band on channel 38. At 12 synod, that's 117. Minus 117, that is. Alright, let's go to AM. Minus 101. Now let's take a look at the AM audio envelope. 2400 hertz at 7 millivolts. Looking pretty good. She dropped right down there in the middle. Nice rounded peaks on top. Okay, let's take a look at the sideband. Okay, here we go. Nice pinch in the middle. And she's not flat topping, she's rolled over the top, alright. Okay, let's do a little bit of a power test. 38 lower sideband. Audio 1, 2, 3, 3 to 1. Audio about 10.3 watts. Go to AM. Dead key 3.6. Audio. About 20 watts peak to peak. Here's upper sideband. Audio 1, 2, 3, 3 to 1. About 10 watts. These radios seem to, that's about all they seem to do on sideband. That's not too bad otherwise. Alrighty. Now here's the second Lafayette Telsat SSB 100. Robert sent 2 of them in, both for VFOs. The first one I already posted, and the VFO worked out really well on that one. This one had some other issues. This one here, the channel selector was broke. Plate inside was snapped. I tried repairing it, but it was very unstable. So I just bypassed the channel selector. No matter where you go on the dial, it makes no difference and no interference. And the volume control was bad. It only went down to 30 ohms, and AM was just unbelievably loud with it turned all the way down. Now it works really well, and the VFO is set up on this one. Let me turn it around here. I set this one up a little different. So you guys let me know which way you think would be the better way. This one I have set up for an external power supply, and I used the record jack with the RCA connector here in the back for the VFO. You come off the VFO and just plug it right in. And that way it looks stock from the back. I still didn't drill any holes in the radio. And there we go. Okay, right now we're on 38 lower sideband. The clarifier works just fine on upper lower sideband, and it's ready to go. Alrighty, you please like and subscribe, and we'll catch you in the next one.